I've been using Zoom, so.
No, I'm recording it here. It's fine.
Oh, lovely. Okay, so I'll just share my screen and get started. Just a second. The other thing that I don't know with Google Meet is if it shares sounds. I think it does automatically. I've had that problem earlier. Okay, good. So if something goes wrong, then maybe just holler or say out or whatever.
Yeah.
Right. For those who don't know me, my name is Aniruddha Joshi. I am a faculty member in the IDC School of Design. And we kind of like a set of very small subgroup of people within ourselves call ourselves as Interaction Design for Indian Needs Group. Okay. It's not, if you Google it, you'll not find it anywhere. So it doesn't exist, so don't bother. Do send me an email if you are interested in our work. I think I have a slide on my email address at the end. Okay, so Nimish asked me to give this talk. So first of all, so thank you very much, Nimish, for organizing this series of events. And I'm really very, very happy to come and share my work. And he gave this title actually. It's called Swarachakra Text Input for Indic Scripts, and I'll actually present some of our work related to Swarachakra. But an alternate title for this talk could have been Cracking the Puzzle of Text Input in Indian Languages. And we don't claim to have done that, but that's the aim or that's the goal. A third alternative title could have been sort of try to show how our work has matured over time. Although I have not really managed to finish this part of the presentation yet, but there is bits of these things that you can see, and if you are interested in discussing that, I'll be happy to discuss that actually. Like how have we matured over the last few years that we've been working on this problem. Right. I must also acknowledge, and I'll do that also during the presentation a couple of times. I must acknowledge the contributions of many, many people who have worked on text input in general from IDC and also specifically on Swarachakra. So I'll try to kind of do that. So I'm just right now making you aware that many, many people have contributed to this work that I'm presenting. Okay. So since the group is small, I thought we could actually do a interactive thing. So I want you to blurt out the answer to the question that I'm asking. So there are different writing systems in the world. So the Indian language writing systems fall in which category or which group? Anybody knows? वहीं से शुरुआत करते हैं कि ये क्या है? So the hint is that it is not alphabetical.
So is it Abugida?
अरे क्या बात है निमिष, fantastic, very good. Right, so most of the Indian languages fall under the Abugidas. We do have, so Urdu is, for example, Abjad, and other than that, there are very few scripts which are not in these classifications. These are the high-level classifications from around the world. There are very, very few scripts of that nature, but most of the Indian scripts then are Abugidas. Right. And so here is just an example of the different kinds of scripts that are there. And actually, if you look at the world map, then of course we are all surrounded by the alphabets. Like all this sort of gray stuff is all alphabets. Basically, all these countries speak languages and write languages that are alphabets. If not, I mean, some of these countries did not start out as alphabets. So, for example, some of the countries in East Asia did not start out as alphabets. So Indonesia and Vietnamese and so on. So many of these scripts, Malaysia, but they were lost actually eventually, and they actually have adopted the Roman script as their fundamental script. Right. So that's alphabets, and we don't do that. And of course, the logographics are the East Asian ones, and the Abjads are more or less the West Asian ones. Okay. So the countries that actually use Abugida scripts. So then India, Nepal, Bangladesh, Burma, and Thailand, and a few countries in this patch. Ethiopia, and in northern Canada, there are some scripts which are supposed to, or are at least classified as Abugidas. I'm not an expert I'm not a linguist, but I'm just saying that So the point of this slide is that this is where most of the innovation needs to happen if you need to actually solve these problems, right? But I have not yet established the problem. So what is the problem? So there are many ways of talking about this problem. So I'm going to just present 2 or 3. So a picture of IDC to begin with. So somebody had put up this beautiful mural on or just outside the IDC auditorium, and because it was delicate, so they had to put up a sign which said, "Please do not touch." So those of you who are typographers might guess what typeface "Please do not touch" is written in. But can you guess what typeface "Krupaya haath na lagaya" is written in? So that's the challenge. I mean, if you have to write 4 words, there was a time when people couldn't type it. Okay, things have changed quite a bit in the last, I would say, 6 to 8 years, maybe 10 years. But before that, certainly this was a problem. So this has then been a problem, and this kind of just strikes home to us in IDC because this is a picture from IDC. But this problem is there everywhere. I mean, if you look at Hindi film posters, okay, I mean, this is targeted for Hindi-speaking people and designed professionally for a very large audience. Okay, and if you see the main typography, you will always find in the Roman script, right? The main typography. I mean, it so happens that the side typography is there, and even if you are writing long sentences, right, you will still probably find many of them written in the Roman script. Changing a little bit recently, but not enough, I would say, or whatever. I mean, not in the mainstream still, right? There are other examples. So this is a particular graph that I like to show. This is the x-axis shows the number of speakers, native speakers in millions. Yeah, so if you're like me, then probably you should cut a 0 and think about it as crores. And it's on a log scale, right? In fact, x and y axis both are on log scale. So like 1 million speakers, 10 million speakers, 100 million speakers, and a billion speakers, and of course there's nobody with 10 million speakers. Okay, so that's the x-axis. Y-axis is the number of Wikipedia articles in thousands. 1,000 articles, 10,000 articles, 100,000 articles, and a million articles, and then even more than a million articles. And actually, a very interesting grouping emerges when we did that, right? So this is, of course, many of the developed countries. So one thing I forgot to mention, the text that is written in green are all alphabets, okay? So Japanese and Mandarin are the only 2 exceptions over there. Japanese one, and Japan is a unique country. Somebody once told me that there are developing countries and there are developed countries and then there is Japan. So that's the scale. So Japan one can understand. And Mandarin has just recently entered the million Wikipedia articles club in the last 2-3 years. All right. But so those are sort of, one can understand that is relatively large number of native speakers and therefore they contribute many Wikipedia articles. This is relatively smaller number of Wikipedia, smaller number of native speakers, and still very large number of Wikipedia articles. And that is very impressive for me, right? Unfortunately, many of our scripts and many of our languages kind of fall over there. With fairly large number of native speakers and fairly small number of Wikipedia articles. And this is, to me, I mean, it's not that Indian people do not have knowledge to contribute. If you made a similar map of YouTube content, it will come out differently. So it seems like it's mainly the text input which is the issue, right? And it's also not lack of technology. So this is a keyboard that's been available from 1986. In fact, at that time, so I'm happy that Deepak is here. So there were 17 keyboards. I don't know if you remember Deepak, but there are 17, 18 different keyboards available back in those days for inputting in Indian languages. And this is one of them. So this is in script. It's been around. Yeah, Deepak, go ahead, please.
No, I was just saying, I remember having several different ways to input these things.
Yeah. Right. So, technology has been available, but I think it's been a design problem. And so one of the challenges that actually was there before was that the keyboards were fixed, and actually manufacturing hardware keyboards was particularly challenging for a particular language. So most countries, including Japan, by the way, mapped their keyboards on top of QWERTY. Okay, and so did we. So the InScript. So this is the QWERTY keyboard. It uses the Roman script characters, only 26. This is 101 keyboard, by the way, but it uses only 26 for text input. Right, and the in-script keyboard actually takes away all of these additional ones that are marked in orange. So for example, let's just look at a common problem. If you need to type a question mark in script, you need to switch out of in script, go into the Roman script, type the question mark, and then come back into the, and then for many other things, colon, semicolon, quotes, and so on. Okay, so why does it matter? I mean, okay, this is a problem, but why does it matter? So there are different ways of looking at it, and again, many ways of answering this question. But this is my way. So this is again, this is our population of India in millions. Okay, so again, if you don't like millions, cut a zero and you get crores. From 1991, time that I was student, till in IDC, till sort of more or less present time, and also projected the future. The red line shows the number of mobile phones in India. This dotted line shows the number of landline phones. This shows the number of internet users in India. This shows the number of smartphones ever sold in India, according to IDC estimates. And this shows, I mean, the same data, but now less than 5-year-old smartphones, because smartphones don't last, even if you make them last for a long time, they don't last beyond 5 years. So that's the less than 5-year-old smartphones in India right now. Right. So now if you kind of superimpose this information on top of this, if you put in any, you can put many different demographics, but I'm just putting education, right? So first of all, already even till 1991, we had 57% illiterates. And in fact, in 1947, when India became independent, we had about 80% illiterates in the country. This number has been in percentage terms declining, and also in absolute terms declining gradually. Current estimate is around 20%. It could be 18%, 22%, and so on. We will know after the 2021 census is done. Probably the 2021 census will probably be in 2022 or 23 after COVID. So maybe we'll know it then. Right. On the other end of the scale, these are the graduates. So about 4.4% in 2001 census, 6.5% in 2011 census. Then this is HSC, diploma, and metric, and then middle school and primary school. So you can see, I mean, these are all, these lines are hand-drawn by me approximately in Google Slides. But it kind of gives you an idea about the fan of education spectrum and how technologies have been cutting through this. Okay, the point that I was trying to make was, there is a large chunk of India's population which we can categorize as non-English literate. Okay, and so while English, which we use in higher education and administration and in so many other fora, very, very routinely, we have a substantial, I would say about 40% of our population, maybe 35% of our population, a third of our country at least, which we can categorize as non-English literate. Depends on where you draw the line. There is also a reasonably good number of people who we can categorize as barely literate and illiterate, but that's not the title of today's talk. So I'm going to talk about this group, which is this non-English literate group. We have, by the way, work. I would love to show work in all other areas also, but I'm going to kind of specifically focus on this group, and within that on text input. Right, and then if you cannot type, you cannot make presentations, write documents, create posters, send a message, shop online, book a train ticket, or search. For doing any of these things, we actually need to have good command over text input. Okay, so this started out as a design project. Okay, much of our text input work started out as a design project, and this is sort of, you can say roughly, I mean, maybe in hindsight, the problem that we were asking. We started out just splashing around our hands and like feet and trying different things. So it was really not so very well spelled out, even as a design problem. But given that typing in Indian languages is hard, as we have seen, how to make a keyboard that is usable by every literate Indian. So that is roughly what we've been sort of working on. And while I'll talk about Swarachakra, I'm also going to touch upon some of the earlier attempts very briefly. Not all of them, but at least a few of them. Okay. And then also in hindsight and after working on this problem, we actually have identified 6 problems, but I'm going to talk about specifically 4 of those 6 problems. So first problem is the number of characters. So, and particularly it's kind of common to compare it with Roman script. So we can see we have just a larger number of characters. Well, not as large as say Mandarin or even many of the Japanese scripts, but still a substantially large number of characters, which don't easily fit onto a QWERTY keyboard, right? But then there are some advantages also, and one of the big advantages is that the Devanagari script, or most Indian scripts for that matter, are pretty well structured. Okay, so I want you to do this little experiment, even if the mic is mute. Put your hand on your throat right here, where your Adam's apple might be, and say "k." So if you do that, you will feel the vibration right there. Okay, and if you say "k," "k," "g," "gh," "ng," all of them are actually right there. Okay, and then the "ch," "ch," "j," "j," "j" are the palatals. They sort of happen at the top of the mouth. The "t," "th," "d," "n" are lingual. They happen just behind the teeth. The top of the mouth, just behind the teeth. "T," "th," "th," "n" are dentals, so you have to touch the teeth to say any of these consonants. "P," "p," "m," you have to close your lips in order to, so they are labials. So you have to close your lips to say this. And by the way, this is sort of, this classification and this grouping is actually language independent. So for example, if you take a word "people," you cannot say the word "people" without closing your lips twice. So you cannot say "he will." You have to close your lips no matter what language. Right, and there are other structures for semi-vowels, vowels, and so on. In fact, if you look at the Wikipedia page, you will find vertical structures, horizontal structures, and so on. So it's a structured script in some sense. And Devanagari is not unique. So if you compare many of the other Indian scripts, Bengali, Malayalam, Tamil, and in fact, they all actually kind of derive their roots from Brahmi. And in fact, it so happens that Brahmi also has Unicode in them. These are all Unicode screenshots in various languages. Right, so that's the benefit, okay? And so while then the number is a problem, so if you can somehow make use of this structure in making this problem easier. So in fact, some of our earliest work started in 2002, so about 20 years or 19 years ago now. And these were some of the people, these are later Facebook pictures, pictures of people who worked on that project taken from Facebook. So they look older, but they kind of worked on that. So we had several. So Amit Rathod actually started out, in fact, as a PD project. So Amit Rathod worked on this as a PD project, and then later on worked with us in Media Lab Asia. So in fact, all of these people. And then we worked on some very interesting layouts, and this one came out as a winner. It was called Key Lake, and we actually went through 7 iterations of the hardware itself. Actually, I'm not presenting that. Another work was Saral. This is Anshuman Kumar's P2 or P3 or something. I don't remember. So he developed, and I don't unfortunately have a video of this, but this is sort of on the Nokia, and my Nokia N95 has stopped working long time ago. It was an interactive system that you could use only with the 4 keys of the keyboard and the mouse. And we actually ran some studies. So Hemruchi was one of the students who sort of ran study to actually assess this and compare it with then existing keypads, which used actually many more keys. Right, and then we come to Swarachakra. So, and then many other people have contributed to this. But I'm now drawing your attention specifically to the layout and the graphic design of the keyboard. So, and if you will see, it has been very carefully structured and detailed so that it is easier to sort of make the groupings, identify the groupings, and sort of go for it, basically. Yeah, so that's probably how we handle the problem of number. And actually, similar strategies were used by different people at even in the hardware and in the software also. So layout making use of the structure was the one part of the solution. Second issue is that of sequence. This slide is really meant for people who don't know what is Devanagari. So the sequence of characters is sometimes confusing, and I'm kind of going to illustrate this with some very basic input, including a consonant and a vowel. So ka, I think the sequence of characters is quite simple, but ki is not, because I think now most of you perhaps know that you have to first enter the consonant and then the iki matra. But in the visual appearance, the iki matra appears first when you read from left to right. Okay. And they appear above, below, to the right, to the left, and of course in different languages in different places. And this kind of adds to the issue of what should be the sequence of input. And this is just for consonant and vowel. Okay. So Swarachakra takes away the need for doing that, because when you touch the keyboard or touch a consonant, it gives you a menu of sorts. So if you go back to the classic old, so this is not a command-driven interface. This is a graphical user interface, basically. So we're just making that a graphical user interface. The third problem is conjuncts, and which we know are particularly challenging to input. And again, for those who don't know, they will agree. So in English, C and L will stand together even if you merge their pronunciations. But in most Indian languages, we have a concept of a conjunct where they will merge together. The two consonants will merge together visually, and their visual merge looks actually different from each other. So for example, kl and kt are quite obvious, but kr, it is not obvious that whether the k is half or full, for example, visually. Or k, it is not obvious that the r is before the k. Okay, and sh is actually, the sh almost disappears, and k also almost disappears. It looks like a different conjunct altogether, and same thing with shra. Right, so there are these sort of points of confusion as far as the sequence is concerned. So to some extent, Swarachakra manages this. So when you are trying to type a conjunct that starts with a b, you move your finger upwards and then you select the b halanta, and the layout of the whole keyboard changes. So it basically provides a dynamic layout, and sort of that helps. Right. And then further, of course, one can attach the wall modifiers to it. Right. So this was originally work of Aniket Sarandar, who was who did this as part of his P2, and he developed several other concepts. It worked well in our studies, so we actually converted that. So first we launched it on Android for Hindi, and then slowly this kind of attracted many other people. So then we started launching for multiple languages. So we had Marathi and Bengali apps. And then we have Gujarati, Malayalam, and Assamese. And each of these were designed by different groups of people. So we did not enforce a single design language in all of them. There are some similarities, obviously, but we formed design teams for each language, and and this is probably the most evident in Tamil. But we actually had a different one for example, for Konkani also, and Punjabi and Tamil and so on. Yeah, so basically we have in all 12 languages, so Telugu, Kannada, and Odia. So, and this again started as an interns project. And then more and more people joined in, and it became some sort of a larger and larger group. And so last year I checked, I used to check it more regularly earlier, I must confess. Over the last few years, I've been sort of sporadic in my checks. But I checked in March, and we had reached around 65 lakhs or 6.5 million cumulative downloads across the languages. Right. The other issue, which I'm not mentioning here, but was the usage. Like even if you have the keyboard, probably people may not be using it. But we actually therefore tracked it for a while, for about a year or so, and we found that actually usage was growing. So this is Swarachakra words typed per active user per month in a period of about 6 months. I must point out here that we were not sort of looking at what you are typing. We were just counting the number of words that you were typing and which words you're like, what is the word frequency of your content. And then this led us to actually a word frequency cloud, which we published in India in 2014, I believe, which basically tells us the real frequencies that people are using and the mistakes that people are making while typing also. So, and this data, in fact, we have put in public domain. It's been in the public domain for the last 7 years. Right. The fourth issue has been speed. So now, to contextualize this a little better, let me ask you a question. Yeah. How fast do you type in English? Anybody knows how quickly can they type in English? Anybody has any idea? If not, you can go to that. There are many hundreds of URLs. You can get yourself an English typing test. Anybody knows though, very quickly, how fast do you type in English? Nimesh, how fast do you type?
I think I must be very terribly slow.
But even with terribly slow, how fast might it be? You should try that actually.
I'll
So a lot
try.
of, yeah. So a lot of people. So just to give you some benchmark. So casual typists. Most of us are casual typists. Like we'll casually type something. So when you're, even if you're not like exerting yourself or whatever, casually typing, you'll probably type at around 20 words a minute or so. Professional typists start at around 25 words per minute and go up to anything like 60, 70 words per minute. Okay. And that actually, so we don't do words per minute in Indian languages usually. We do characters per minute because words per minute is harder. So you have to multiply by 5. So you typically do casually when you're typing, you do about 100 characters per minute. And 200 is common. And 300, 400 is also not impossible. Okay, so that's sort of the benchmark. Okay. So we've been doing some studies. Thankfully, this part of the project, this part of our work was thankfully funded. So we could actually travel and go to different parts of the country. And in fact, this was a part of a larger project run by the government, by DIT, on virtual keyboard standardization. And we kind of decided to work with children. So, and we kind of, in our study, so we were given, our team was selected for doing 3 languages. So Marathi, Gujarati and Telugu. We could ultimately do only Marathi and Telugu. But anyway, so, and for Marathi, we compared these 4 keyboards in probably the most rigorous study that has ever been done on Indian language keyboard. This was published in Mobile HCI 2016. And we compared here in script with and without prediction. So the first keyboard is actually a well-known keyboard called SwiftKeys. Perhaps some of you guys use the English version of this one. And so SwiftKey also had an Indian language version for most Indian languages. And so at that time, when we did this study in 2015, Google Indic did not exist for Marathi, and they were just recently launching for Hindi actually at that time. Otherwise, we would have loved to include Google Indic as well. So this is CDAC's keyboard. You can see the logo there. So if you look at it carefully, they are similarly, the same layouts, but with some minor differences. So this one has prediction. This doesn't have prediction. This is a flat keyboard. This is another very good keyboard called Sparsh, which has both prediction and pop-ups, just like Swarachakra, but the pop-up shape is different. And of course, Swarachakra. So we compared these 4 keyboards. I could make a separate presentation about this, but to cut a long story short, most keyboards didn't do very well in terms of speed. So after about 5 hours of practice for the users, we started them on scratch. These were all kids who had never used smartphones. The studies were done in government schools. After 5 hours of practice, students could start around 15-20 characters per minute and could reach between about 38 to 45 characters per minute. Happy to note that Swarachakra did best among these, but to kind of quote a Marathi saying, Vasarat Langdi Gai Shani, which means basically, it's really not much of an achievement. So this has been, speed has then been a problem in Indian languages. Swarachakra does well. In fact, I must also add that Swarachakra does well in spite of it being a very dumb keyboard. Okay. So SwiftKey, for example, when I used SwiftKey for the first time, I said, my goodness, this is going to beat Swarachakra hollow. But in fact, it turned out to be the worst performing keyboard at the end. And the reason then we went back and see, okay, so it has all these predictions and bells and whistles, and it has swiping and flow writing and so on. And we taught the users all of these. But basically, the layout itself is so complex that people could not really remember and memorize it even after 5 hours of practice. So that's about the amount of time that anybody will possibly spend in trying to learn to type in Indian language. So we sort of said, okay, chodo. Right, so speed has been a problem. And then around that time, actually, voice technologies were becoming available. So I hope you can hear the sound here.
जबलपुर जाने की टिकट कितने की है? जनगण मन अधिनायक जय हे.
So of course, voice is inaccurate, so you have to go and edit it. So one of the challenges we wanted to know was that, given that voice is inaccurate and can make mistakes like this one, how accurate or how beneficial is it going to be for people to do this?
आज इंडिया की लड़कियां लड़ाकू विमान चला रही हैं.
And so on. So it kind of keeps going like this. So we ran a study of keyboard only versus keyboard plus speech. Again, this was I'm not going to go into the research aspects of it. It was published in India, it's 2018. So to cut that long story short, so we had substantial gains in speeds. So what we did was we started people by teaching them. This is again completely no voice users. Started around 18, 19 characters per minute, ended up and started saturating around 45. Then we split the group into two. We gave one of the groups speech, did not give other groups speech and let them continue. They very gradually rose till here about maybe around 45, 50. And then gave the other group the speech, and then the first group came down again and so on. So it was just a counterbalance study, usually a standard practice. Right. So we could actually achieve about 100 characters per minute with speech. So we got a paper on this in, what did I say? Indic. Yeah, 2018. So this was sort of around the time when speech was available. By the way, now again our speech has gone because we were actually collaborating with a startup which got acquired by Flipkart and they shut down their API. So we don't have speech anymore on Swarachakra. But anyway, so meanwhile, we also started on a project on accessibility and we did several other accessibility projects. But this particular one was about making Swarachakra accessible. And I'll actually, so perhaps many of you have never used an accessible keyboard. So let me first begin by showing you a demo of how keyboards are made accessible on touchscreen phones, basically, where you don't have keyboard. I mean, the older phones, the Nokia phones, the feature phones or the basic phones that we sort of used, had the multi-tap with T9, if you are old enough to remember that. This was followed by those BlackBerry-style large keyboards. Nokia also had a bunch of phones and so on. So where the full keypad was given. So those phones are sometimes classified as early smartphones, but they didn't really last. I mean, BlackBerry folded up and so on. Nokia folded up. So these devices didn't really last. But blind users really were clinging on to these devices. Even this is studies done in 2018. They didn't want this to go because they enjoyed the tactile feeling, as you can imagine. And actually they were pretty fast with those, right? But eventually all those, how technology companies work. So eventually all those good things went away for blind users and they were actually left with touchscreen phones without any features to touch, right? So text input has been, I will not say solved, but actually handled. So by a method called, there are some variations between the iPhone and Android and so on, but basically what is called Explore by Touch. So this is Rini Ahirwar. She is one of our colleagues. She was a research associate for a while in our lab. And she is trying to type her name, Rini Ahirwar, so remember her spelling, okay?
Capital R T T Y U I S X C V V J J N November N N G H U I home button space Shift A and caps lock enabled. Capital Z, capital X, capital X, X-ray, capital Z, capital S, capital S, Sierra, capital S, capital V, capital F, capital G, capital H, Shift, capital A, Alpha, Shift sequence.
So she gave up. So she was trying to find capital A for Ahirwar, right? So, and of course, around this time also Google Indic had their, just a second. So Google Indic had their own accessible keyboard, thankfully also.
Samachkar. Ka. Ta. Pa. Go to page 2. Sha. Sa. 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 Ka. Ta. Pa. Fa. Pa. 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 Ka. Ta. Ka. Ga. Ka. Cha. 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 Pa. Ta. Ka. 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 Ta. Pa. Fa. Pa. 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 Ya. Ra. Ra.
Right. So this is Google Indic's accessible version, and this is quite similar to English. Now, if you remember the interaction technique used in Swarachakra, you'll remember that as soon as you touch the keyboard, it throws out a chakra, right? So this explore by touch will not work as it is out of the box for Swarachakra. Otherwise, it would have been, because it's an interactive keyboard. It has all these interactive bells and whistles, and so how do you make this accessible? So that was what this project was about, basically. How do you make this accessible by the blind? So I had another intern. His name is Pabba.
Up, Raya, Ta, Ta, Pa, Ra, 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 Raksha, Sheher, Sha, Sha, Ta, Ta, Pa, Ra, 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 Nilaka, La, La, Sa, Kalyashala, Ta, Ta, Pa, Ha, Hanmaz, Ra, Ra, Na, Na, Na.
Right. So if you sort of could see that was a real dark video, but if you could see this, by this time most of the devices were what is called as multi-touch. So you can touch 2 fingers or 3 fingers, or some devices can also handle 5, 6 fingers 8 fingers at the same time. Okay. So, but most devices are 2 touch at least. Okay. And so this is actually taking advantage of that Android devices. So you kind of explore by touch by 1 finger. Once you have located the key that you are looking for, you put the other finger down and then you sort of select that. Right. Okay, so we sort of evaluated, or we compared Google Indic with Swarachakra with about 10 blind users. This one, so I am not focusing here on the research part of it, but this was our within subject design, which is one of our first studies, which was within subject. All our earlier studies were between subjects. So if you want, I can give the same slides and talk about our maturing research over a period of time. And again, so lower speed, of course, than sighted users, starting at as low as 5 characters per minute, and then going up to around 15 characters per minute in the first round, and then we flipped, right, attempt 1 and attempt 2. So we flipped it, and then starting at around 10 to 15 characters per minute, and then going up to about 20 characters per minute in about, after 20 sessions. So if you see the red line, which is Swarachakra, is more or less consistently above the blue line, which is Swarachakra. Again, Vasara Pragliga Shani, which means basically not much of, Google Indic is also not a great keyboard. So we are doing better than that. And the good thing about Google Indic though is it has all the power again of AI and whatever. Google's intelligent keyboard design team has been working on it. Right? So they actually use all that technology. Swarachakra is still a dumb keyboard in comparison to that. Right, so we published this in Interact 2017, incidentally a conference that was organized in IDC, and happy to note that we got the one of the top awards of this conference, Interaction Design for International Development Award, 2017. So this is our picture. Right, and I think this is my second last project, and then I'll get into something else. Yeah, so this is. So meanwhile, of course, as I said, the speech thing had come in already. So we actually, speech recognition. So we actually, this is our work in Interact 2019. So this is Marathi now, not Hindi. So with some minor variations, it's the similar design. So I'm going to sort of skip the whole video. And then also it worked with voice with again some minor variations. So I'll just show a demo of 2 lines.
नाचरे मोरा आंब्याच्या वनात.
नाचरी मोरा आंब्याच्या वनात.
So it makes mistakes. And you do.
नाचरी मोरा आंब्याच्या वनात. नाचरे मोरा आंब्याच्या वनात. वनात आंबे मोरा नाचरी मिटवले.
नाचरे मोरा आंब्याच्या वनात.
नाचरे मोरा आंब्याच्या वनात. नाचरे मोरा आंब्याच्या वनात. नाचरे मोरा आंब्याच्या वनात.
So if you see, there is still a problem. There is a less space in that, so which the blind user cannot make out. So anyway, we ran this with 14 visually impaired users. Only 11 could complete. These were again kids in a school in Nashik. Yeah, and here the speeds when they were in the keyboard only conditions. And this was a shorter study also because blind users take much longer time to complete their work. So we had to actually run a shorter study, otherwise we couldn't have completed the study. So their mean speeds were about 16 towards the end, 16 characters per minute, which is not different from what the earlier study showed for Hindi. But when we gave them speech, it went up to about 180 characters per minute. So there was a huge jump. In fact, if you remember the earlier one, the sighted users were doing 118 characters per minute. So compared to that, 182 characters per minute, we will take with both hands. Right. Also interesting was issues about, blind users unable to kind of like tell the difference. This is just like, you cannot tell the difference between output and output, right? I mean, there is it's very hard when you are listening to tell the difference between these. Similarly, we had a whole bunch of those kind of errors. So we ignored such errors during the test because otherwise we would discourage the users. But when we wrote the paper, we actually did a strict study. And so this is a comparison with our Hindi India 2018 paper and Marathi Interact 2019 paper. So we actually generally follow two types of errors. One are called as corrected errors. So this is the corrected error rate and this is the uncorrected error rate. So usually uncorrected error rates are quite low for sighted users. If they detect an error, they can fix it. For at least on a good keyboard like Swarachakra anyway. But it was higher for visually impaired users. Although the speeds were higher, the uncorrected error rate was much higher, and corrected error rate was not somehow that much higher. Right? Again, another award-winning paper. We got the Reviewer's Choice Award this time. Right. So over the last several years, more than 100 people have contributed to. Many of them are our students and now our alumni who have contributed to our work on text input and specifically on Swarachakra. And so I only hope that we have not missed out naming some people here. We might have actually. This doesn't count to 100, but I know that there are more than 100. Right. Nimish also asked me to actually, so I said, do you want me to give a standard talk? So I said, so he said, yeah, standard talk is okay, but also tell us how IDC alumni can contribute. So these are some really hurriedly put together slides on what I believe and whatever. And these are actually, here I must apologize because I was really trying very hard to make them complete, but I missed out many names. I know that. And so I hope to complete them eventually. Right. So first of all, developing Swarachakras, because the topic of this talk is Swarachakra. So this started as Aniket Saranga's P2. Many people have been maintaining it, but probably the biggest contribution came from Manjiri, who has maintained this free of charge. So I did not emphasize this. Swarachakra has been a zero budget project. We haven't invested, we haven't spent a rupee. The only money that I spent was when we reached 1 lakh downloads, I went and bought some pedas. So that's the kind of money that we spent on it basically. Right? And many other people. Prasad actually worked on a more interesting prediction mechanism for Swarachakra. Narendra Parmar worked on creating a literacy program using Swarachakra. So it's still related to Swarachakra in some sense. Then there's a whole bunch of people. I can see Kaustubh. Hi, Kaustubh. A whole bunch of people who have worked generally on Indian language text input beyond Swarachakra. So Sanjay Ghosh did his PhD on that space. Kaustubh did a very interesting game. Kaustubh, make it work here. It's still broken on Play Store. It's available on Play Store. It works on some devices, but it needs to. It's not been updated for a while, and Google keeps changing its policies. Aniket worked on several other text input mechanisms. Rupesh is doing his PhD with us. Amit Rathod, 2002. Prashant Sachan worked on a one-handed keyboard. Anshuman Kumar was the one who did the N95 version, and Emruchi is the one. So I'm not going to call out now. More names will come. Beyond text input, we have been doing lots of interesting work. So Swarachakra, so some is related to Swarachakra, but not Swarachakra. So Swarachakra generates a lot of word frequencies in 12 Indian languages. Original word frequencies, what we call natural word frequencies of what people are typing. But they are messy, they are unclean, like they have many errors in it. So both Vivek Paul and Tarun Mugunthan, so Vivek Paul is a MDes student, I believe, from 2018. Tarun passed out last year, he's a BDes student. They worked on a corpus cleaning game or a word frequency cleaning game, so a gamification of the cleaning activity. Interesting ideas. Prem Lokesh, Shubhangi Salinkar, both of them worked on two interesting projects. Prem Lokesh worked on teaching Marathi to Hindi speakers, a project to teach Marathi to Hindi speakers. Shubhangi worked on teaching Hindi to foreigners who are living on the IIT Bombay, or foreigners in general, who are outside India. Rekha worked on teaching Kannada. Kirti and Nikhil worked on localization. There is a huge area of work that I have not mentioned, which is localization. Amrita, Rishikesh, they all worked on language-related projects at different times, right? Broader issues that I am not even talking about, you'll need to call me for 3 more talks. One is for emergent users, so there's a whole bunch of people who have worked on for emergent users. I'm not going to call out all of their names. Some people have been working on education, and I would say most recently we've been also working on accessibility. So there's been a bunch of work. And of course, this is just sort of interconnected work. We tend to kind of work even on broader issues in IDC. So I think IDC alumni can contribute by being associated with all of these. But this is sort of a little vague, I thought, after I created the slide. So I just kind of added one last slide, which is a more direct answer, basically. So 99% of IDC projects stay on the shelf. I mean, all of these are brilliant ideas. Many of these are workable, brilliant ideas. But student finishes his project, moves on, or intern finishes his project, moves on, right? Or maybe at the most, we write a paper, okay, and win an award. But beyond that, 99% projects stay on the shelf. So some of these ideas definitely are worth taking beyond the shelf. We have learned that from Swarachakra, we have learned that from Tama, which is our HIV project. I don't know if you guys have heard of it. We've heard, and not only in like commercial deployments or whatever, public deployments where these have been, but we also, the user research model, which Devanuj contributed, for example, is used not only by us in other work, but also by people from other universities and research groups also. So, and that is also another way of going beyond the shelf. Okay, what can you contribute? We would love to host people who want to come for a 6-month to 1 year sabbatical in IDC. It's a in the works thing right now, but this is a proposal that I've been working with some colleagues. And if any of you guys want to kind of give it a try, we can help you stay on the campus for that period. We'll find accommodations for you and whatever. You can help us with contacts. So, for example, if you know somebody who wants to, get into a startup, has some similar ideas, and then you want, that's an option. We don't really have product management expertise. So, if some of you guys have fantastic product management expertise, who can and volunteers who can design, develop, and support the long tail. Swarachakra suffers from the long tail problem, by the way. So the biggest complaint against Swarachakra is that its English keyword is really bad, not about its Indian language keyword. So that's another issue. Money is most welcome always, especially non-corporate, non-startup, non-government funding helps in a big way. Because all these funds are very useful and they have driven much of our research, but they always come with some other goal and not sort of aligned to what we are trying to do. We kind of cut corners on the side and try to work there in some of these areas. And I think this is a suggestion that I've been making alumni, and some of it has been working through the awards group. There's a group of people who are actually trying to run the alumni awards from year to year. They're struggling, but they're working very hard. But we should probably also set up a steering committee set up by the alumni to direct alumni involvement with IDC. So I think that will be really very, very useful. Thank you very much. I appreciate the time. I will be happy to answer any questions.
Thanks, Aniruddha. I mean, very insightful. I think we have a lot of questions. So, guys, anything that you guys want to start with? See, I have one, so maybe I'll start with. Do you have any patents on this?
I do have two. We applied for 2 patents in my life. First one was, in fact, a text input. So there's a keyboard that I showed called Key Lake, and we applied for the patent there. We went through the process of patenting, and it was an exhausting process for me personally, at least. So I decided to then put all our future work in open source after that, and not bother ourselves with this. And I know that a lot of people, a lot of our students have many patents, and I'm really proud of them. But I believe at least IIT Bombay is not very that well set up. In fact, one of the, oh, you're recording, so I'll not tell you some inside story. So yeah, let me leave it by saying that, we are not a corporate. We are not set up to sort of create patents easily and defend them even if there were violations. So, but yeah, so I tried it and gave up and decided to go papers and open source it.
Right. So one question, maybe others can also pitch in. What is your long-term goal with this? Is there a long-term goal that you have for Swarachakra?
For Swarachakra specifically?
Yeah.
So in fact, I sort of am sorry to say that for the last 2-3 years, we have not had much of a long-term goal. Well, we worked on it for 6-7 years, so that's a long enough time for a university-led project, which is zero budget and self-funded. But what I would really love to do, is to make it a smarter keyboard, basically, or which it is not. It is a dumb keyboard. So design-wise, it's brilliant. Technology-wise, it is sort of basic. So, so that is one thing. I have tried to work with this with interns, but it doesn't seem to be working. I mean, I've tried. Maybe there is some panvati in that, but we have tried like with 5-6 interns. They start it, they do it halfway, but actually it takes a little bit more than actually working with students and interns to be able to do something like that. Yeah, and so we also tried to approach Google. Bola ye open source keyboard hai, le lo, but Google didn't give us manpower. Google, you are listening, I'm sure, in Google Meet, so please.
But Google Indic is also very, very similar, right? I mean, while it's not in context, but on the top row they give you.
Yeah. No, there are many variations. So then one has to get into things like Fitts law and so on. Then so if you just do a basic Fitts law analysis, Google Indic, Sparsh was actually before that. Sparsh is better than Google Indic, I would say, and Swarachakra is better than Sparsh. That Swarachakra better than Sparsh, we have evidence for. Google Indic is also, we do have evidence for that, but not as good. We don't have a paper on that.
Sure.
We have a paper for Google Indic versus Swarachakra in the accessible version.
Is there a Git repo or something of Swarachakra?
Yes. Okay. Yeah, so if you want, so Manjiri is the person. So if you, Deepak, I can connect you to Manjiri. If you can connect us to any set of developers, it is on Git.
Okay. Is there an iPhone port for that?
No. So again, so as you can see, I mean, all of this is volunteer development work, and so this is that long tail part of it that I was mentioning, Deepak.
Right.
So iPhone port, making passwords or whatever. I mean, not taking passwords, but when you, Deepak, you know that when you go into a field where you accept only numerical characters, your keyboard layout changes, right? So there is a whole bunch of keyboards, interaction between the app and the keyboard actually. And so supporting all of that, and then that keeps changing. I mean, Android keeps adding stuff to it and so on. So we are well behind on all of those things. And that is actually, in fact, in our first version of Swarachakra, we didn't even have English input. So people complain about it like enormously, because to switch keyboards is not easy. So then we added, English also. But then even our English keyboard is like very, very basic. Yeah, but Deepak, if you want to contribute or put us in touch with people who would like to contribute, we can actually, I will be happy to help or whatever.
Yeah, I will get in touch with you. Are you on that WhatsApp group? You have?
I'm off WhatsApp. I'm on the group, but I don't read.
Give me your
WhatsApp.
email address.
Yeah. Aniruddha at IIT.ac.in. I'll put it in the chat right now. Yeah, that's my email address. Please feel free to anybody to get in touch with us. We are also, since Mandar kindly invited his students to join. Hi Ruchin also. So we are also always looking for interns. COVID has put us back a little bit on that, but otherwise interns come to the campus, have a good time during the summer and so on. Right, so right on dot at 10 o'clock.
So maybe we can have one parting question, and that could be, what else outside Swarachakra are your interests and something overlapping?
Yeah. So there are many actually. So we work in this broad area of emergent users, people who are new to technology and so on. So literacy, education, healthcare, fitness, accessibility. So this is just like within this Indian language stuff, localization, learning Indian languages. Like we know how to learn Japanese, but we don't know how to learn, Nimish, you are staying in Bangalore. How much Kannada do you speak? So I have a student, BDES student right now, who is trying to develop Kannada tutorial for people like you.
Okay, sure.
So a lot of those. So I mean, we try to justify the name Interaction Design for Indian Needs.
I suggest that Aniruddha gives one more talk on the illiteracy and all the other subjects that he's covering.
Yeah,
it's really, really inspiring.
Yeah, absolutely. We should.
Yeah, sure. I would love to. I love the sound of my own voice, people have told me, so I will be willing to give any number of talks. No problem. Thanks. So thank you very much, Nimish, for initiating this and organizing this.
And thank you, Aniruddha. Thank you for taking the time out. I think it was very fruitful. And I'm sure this is just the beginning and we'll have more such talks.
Sure. Thanks. Bye, guys.
Thanks, guys.
Awesome.
Bye.
Awesome.
Hi, Ruchin. I have not seen you for many years. Sham is here. My goodness. This is long. Many known people. Just looking at who else is there. Yogesh, hi.